Okay, folks, so here we're back going over number 11 on the Math Lab homework from section 0.6 in trigonometry. And your numbers may differ slightly. We started going over this today in class as a recitation. And sine x is equal to negative 0.3. You may have had sine x is equal to 0.8 or something like that. But remember that when I look at a problem like this and we want to decide on the expression for x, if we're talking about 0 to 2 pi, it's a little easier. It would just be the first part of this problem, and then you would get your two angles, or sometimes it's only one angle, but you get your two angles, and then you would decide about the k pi or the k times 2 pi, where k is an integer, and what your expressions would be for the domain from negative infinity to infinity. So once we do that, remember, and I just put a couple notes on this, where sine x is equal to negative 0.3, so we have our input is an angle to the output ratio. And then when we do the sine inverse, we're using sine inverse second sine on your calculators of negative 0.3, which is our input ratio. We're going to output the angle. So then we get x is equal to negative 0.304674692. And so recall that we put that in the coordinate plane. And remember that we had those all students take calculus, which gives us the sign. All are positive in quadrant 1, sine is positive in quadrant 2, tangent is positive in quadrant 3, and cosine is positive in quadrant 4. So we know that the sine is negative in quadrant 3 and 4. So those are the two quadrants we're looking for angles in. So the first step, we have to decide on the expression for x from negative infinity to infinity in the problem. So we're going to start then with step 1. We're going to find our angles in one rotation for 0 to 2 pi. So from 0 to 2 pi, we know that our answers are going to lie somewhere in quadrant 3 and 4. So we use our reference angle that we got in the previous step, negative 0.304692, and then we put that in there. And keep in mind that we know that in the quadrant, 90 degrees or pi over 2 is 1.57 radians. But what I do is I set this up so that I know that the sine, remember sine that we have here, sine of an angle, I'm just going to put A, is then going to be equal to the, I'm going to say the vertical, so just so you see it like as if we were looking at the y value over the r value. We don't want to use y's and x's in this case. So you can see that if I wanted to, I could say that just to get a glimpse of what this would look like, it would be negative 0.3 for that side of the triangle, negative 0.3. And then we could say that this side, the radius is then, of course, 1, okay? And I could say r is equal to 1 there. So you see that you have that y over r ratio. So I'm saying that my dimensions are pretty close, but I've just got to say, since my answer is not 1s or 0s, I'm not on an axis, so I can pretty safely draw a triangle. It might not be correct dimensionally, but I can pretty safely draw a triangle. And using that ratio, I'll make the denominator equal to 1. So what I'm really saying here is negative 0.3 over 1 for that ratio. So now, after I look at that, set up my two triangles. Keep in mind, these are right triangles. And then we're going to say, all right, well, we have to decide what our two angles are. So now with the first angle that terminates in quadrant 2, we're going to call that x sub 1. We know that if we go, let me do this first here. Let me get hot pink highlighter so you can see this clearly. So if I go like that, that is an angle that sweeps through pi radians. I know I'm going further, I'm going to here, so you can see you're just adding that 0.304692. So you see that's what I did for this x sub 1 down here, right? Okay, so I get then 3.446, right? Let me erase this so we don't have too much here. And then pick another color, let's go blue. So now to get x sub 2, remember what you're doing. If I go all the way around like this, that gives me an angle swept through of 2 pi, a complete revolution. So you can see that I kind of have to back it up 0.304692. So in that one, I'm going to take backing it up is a takeaway problem, right? So you end up getting 3.446 for the angle that terminates in quadrant 3 and 5.978 for the angle that terminates in quadrant 2. Okay? All right, so enough there. Now let's scroll down. So we have our two angles within, and you're looking at them and you might say, I don't even know what those are. But yeah, you do. Think about it. 5.978 is a little less than 6.28, which is 2 pi. A little less than 2 pi radians, right? And then where you terminate in quadrant 3, you know that half a revolution would be pi. So 3.446 is a little more than pi. So it makes sense. And again, we're only going from 0 to 2 pi. All right, now number 2. Now each time we add k pi or k times 2 pi, we have to consider what's going to happen. So in this first situation in problem number 2, you can see that what's happening is that when we add k times pi, multiples of pi to the angle, x sub 1 plus k pi terminates in quadrant 1. Okay, you see that over here, right? And x sub 2, when we add k times pi, that's always going to terminate in quadrant 3. Think about it. All you're doing is adding. If I start off with x sub 1, let me get a blue here. So if I start off with x sub 1 and I terminate down here in quadrant 3, think about this, and I add pi, that's going to take you to right here. In other words, the original angle then would be this. So it's terminating in quadrant 1. It's not giving you the same result. You need to have the same result when you add k pi. You don't, so that's not going to be your answer, okay? Then if we add 2 pi to it, you can see what happens is that if we take the first angle, x sub 1, and we add k times 2 pi, that's always going to be coterminal. You're going to always end on the same terminal side. And the same thing with x sub 2 in blue where the angle sweeps out. If I go all the way around and add 2 pi to that, here, let's do that for this one. So if I add 2 pi to it, you can see that I'm going to add 2 pi and that'll put me back at the same coterminal place, making the original angle when I add the 2 pi looks like that. Okay? So that is our answer. Okay? So x sub 1 is equal to 3.446 plus k times 2 pi, this one. And then x sub 2 is equal to 5.978 plus k times 2 pi. That represents the solution set over the interval from negative infinity to infinity. Now, when I do something like this, it seems kind of nebulous, right? So it's always a good idea to check it out. When we look at k equals to z, is an element of z, sorry. K is an element of z, the integers. So it's not going to be 1.5. It's not going to be 3.16. It's going to be k is equal to 1, 2, 3, or k is equal to negative 1, negative 2, negative 3, and so on. So let's look what happens when k is equal to 1. So we end up with these two results here, right, in this box. So once I have those results, you're looking at those and you're going, okay, I kind of got that. Not really sure, but let's see what it looks like. So x sub 1 is equal to 3.446. That's our initial one over here. So once we have this, when we check it with k is equal to 1, then x is equal to 3.446 plus 2 pi would give us 9.729 radians. So that would give us the same terminal side as you go around with the purple angle at 3.446. We're adding 6.28, and that makes sense, about 6.28 plus 3.446, 3.446 would be 9.729 radians. And then you can see the same thing with the 5.978. If we add 2 pi to that, we'll again end up at the same place, the terminal side of the angle in quadrant 4, and we'll have 12.261 radians. One last check that you can do is you can say, all right, what do we have? We have sine x has to equal about negative 0.3, right? Okay, and that has nothing to do with the negative 0.304, by the way. those two numbers are not, they just happen to be in the same equation in terms of the angles itself. But if I go back and I put these angles in, I can say, all right, let's do the sine of 3.446 and do the sine of 9.729 and see what we get for our answers. And then you can also do the same for the sine of 5.978, and then again the sine of 12.261. And you should get the same thing for all this. Now keep in mind, are you going to get the same ratio, negative 0.3? Because those are your x values that I put in the parentheses. It might be slightly off because recall that what we did with the decimals is we rounded to 3 decimal places, okay? It was that our objective was to get the angle. So the angles are accurate to 3 decimal places, but they're not going to produce exactly negative 0.3 for the ratio, okay? So I'll let you check that on your own, and I'm going to send this. Have a good weekend, and make sure you check over your agenda and what is due for Monday, okay? Have a great day. Remember, your quiz is due on Sunday, and make sure that you get that in my math lab. All right, have a good one. It's Allenator out, and I'll see you Monday.